Hi, this is Mrs. Bolin with your notes for 4.2 linear functions. We are going to start by going over the warm-up for today. So the first question is, let's determine whether each relation is a function. Remember, what we do for that is we take a look at the inputs and we check to see, are the inputs all different? If they're all different, then automatically, yes, it's a function. But if we have two that are the same, we need to check to see, does this function give me the same answer every time for that same input? Well, the first time I plugged in -2, it put out a 4. The second time I plugged in -2, it put out a 5. Okay, so this one would not be a function because it gave me two different answers for the same exact input. The way that a function behaves is every input that I put in will give me only one specific output. Anytime I put the same input in, it should give me the same input out. Sorry, the same output out. Okay, so this one is not a function because -2 has two different outputs. So now we're going to look again at our inputs, 0, 1, 2, and 3. Those are all different, so automatically, yes, it is a function. The only time it's not a function is if the same input goes to two different outputs. Okay, question number 3. This one I can use the vertical line test. So is there any vertical line I can draw that will pass through the function more than once? Nope, every single one of these lines I draw can only pass through the function one time. That means that each input has only one output. It's totally fine that -2 has an output of 2 and +2 has an output of 2. Totally fine. But when I plug in a +2, there's only one answer it's going to give me. So that means, yes, it is a function. Okay, question number 4. I can use the vertical line test on this one as well. So I'm going to draw a vertical line everywhere I can through my function. See, is there any vertical line where it passed through twice? And yes, there is. So that means that this input has two different outputs. So that is not a function. Okay? And so today we're going to be putting the fun in functions, and we're going to be determining if a function is linear or nonlinear. Linear, just like it sounds, has the word line in it. And so in order for it to be a linear function, the graph needs to be a straight line, but not vertical, because a vertical line automatically would fail our vertical line test, right? So not a function. Even though it's a line, not a function, because that one input has like a bazillion D outputs. Okay, in order for it to be a linear function, it has to have a constant rate of change. And if we're looking at the equation, it could be written in this form where y is equal to something x plus or minus something. Okay. The next thing we're going to talk about is if it's discrete or continuous. Discrete means that there's only certain values. Like if I ask you, what's your shoe size? You're going to say, oh, it's a 7, a 7.5, an 8. If you're a girl, maybe if you're a boy, you might say, oh, I wear a size 11. You're not going to say, oh, I wear an 11.126953.2, right? That's not a thing. Shoe sizes are discrete because there's only certain values. But if I'm talking about my height, that would be continuous, right? I didn't, like as a baby, jump from 2 feet to 3 feet, right? I hit every single value in between as I was getting taller and taller and taller. Okay, so that would be continuous. It contains all of the values within a certain interval. All right, so question number 1, is the function linear or nonlinear? Well, does it make a straight line? No. So this is non-linear. And remember the word linear, go ahead and put a box around that word line. Straight line is what it means. It's okay if it's diagonal. It just can't be vertical. Question number 2, is this one linear? Yes, this is linear. It's a straight line kind of going on a diagonal. It has a constant rate of change. So this one is linear. L-I-N-E-A-R. Okay. Question number 3. Well, for this one, we need to see, does it have a constant rate of change? Well, x goes up by 3, up by 3, up by 3. So that looks good so far. This one goes down by 6, down by 6, down by 6. So yes, this one would be linear because it has a constant rate of change. So you would say, it says, is it linear or nonlinear? So we would write linear. Question number 4, we're going to look at this one, see if it has a constant rate of change. So we'll look at the x's. That one up by 2, up by 2, up by 2. This one up by 7. This one went up by 11. This one went up by 15. So is that one linear? No, it's not. It does not have a constant rate of change. So we would say this one is nonlinear. Okay. This one, is this in the form y equals mx plus b? Yeah, m happens to be 1. B happens to be 9. So yes, this one is linear. Question number 6. It doesn't matter that these are backwards. The problem with this one for the y equals mx plus b is that it has an exponent on the x. If the squared were on a 5, that would be fine because we could just go 5 squared is 25. But when the x or the variable is being squared, that is non-linear. That will actually look like this. Well, that one's a negative, so it would look like a frown instead of a smile. But that's a parabola when there's an x squared on it. So it looks like a U, either a smile or a frown. But it is non-linear because of the exponent. Okay, question number 7 is linear. So even though it's got this funky fraction, the x is in the top of the fraction, which is fine. So I could rewrite this as y equals 0.6x plus 0. So that is in the form y equals mx plus b. It doesn't matter if b, oops, sorry about that. Doesn't matter if b is 0. It doesn't matter if m is a fraction or a decimal. I have a plain old x, something being multiplied, and it doesn't matter what we're adding to the end there. So yes, this one would be linear. Question number 8. Okay, right away, you guys hopefully notice that there's this weird square root thing happening to it. So even though it looks like y equals mx plus b or minus b, it has this weird funky thing happening to it. Okay, so that would actually be a parabola turned on its side, but only half of it, just the positive values. And so this one would be nonlinear. Okay. Question number 1 in our homework. So what I would like for you guys to do is go ahead and hit pause on the video. Try problem number 1. All you're doing is determining, is it linear or nonlinear? Write one of those words and then hit play when you're ready. So this one does make a straight line. It's not a vertical line, so I know it is a function. So this one is, in fact, linear. Okay. Question number 2, you guys are on your own, but think through. Is it a straight line? Yes or no? If it has any curve to it, it is nonlinear. Question number 3, we're going to look for a rate of change that's constant. Plus 2, plus 2, plus 2. So far, so good. Plus 6, because even we're going from 9 to 3 because we're starting at -9 and going up to -3, we're getting closer to 0. That would be a plus. Then this one goes plus by 2. Then this one goes plus by 4. Okay, so there is not a constant rate of change. So this one would be non-linear. Question 4, I'd like for you guys to try on your own. Do your best. You still have to do the odd or the even problems. I'm not going to give you the answer on those. Okay, so think about, does it have a common rate of change? It's okay if it's minus instead of plus, if it's still a constant rate of change. Okay, number 5, could I rewrite this so that it looks like y equals mx plus b? Absolutely, if I just switch the x and the 7. So this one is a linear function. Question number 6, think about what would happen if I distributed this. So if I go y equals 4 times 8 is 32x, so far so good, right? But what about here? 4x times x would be 4x squared. Anytime there is an exponent on the variable, it is not going to be linear. Sorry, an exponent that's not 1. Okay, so we have a non-linear. Oops, I just realized that was an even problem. Okay, you guys got a freebie. Okay, question number 7. This one we're going to see, could we get it into y equals mx plus b form if we tried? So I'm going to go plus 2/3 y plus 2/3 y, and then I'm going to try to get the y's all together. And if I have 1, that's the same thing as saying 3/3. So if I add those together, I would have 5/3 y. And then if I added the x over and canceled that one, then I would say equals 3x. And then if I multiplied by 3 to get that out of the bottom, so times by 3. And then if I divided by 5 to get that out of the top, so divide by 5, I could get y equals 9/5 x. So even though that was a big old funky problem, if we just have y's and x's, we can get it to a point where it looks like y equals mx. And it's okay if there's nothing at the end there. B would just be 0. So yes, this one would be linear, even though we started with something that looked kind of funky. Question number 8. Oh, these ones, you know, you guys, there weren't any of these ones in our practice problems. It was in the notes, but I'm going to help you guys out on these ones. Okay, so this one just is asking, is it discrete or continuous? Remember looking in our notes, discrete was like what I was talking about with shoe sizes, right? There's only certain values. You can't wear like a 4.75 size shoe, right? You can't wear a square root of 17 size shoe. It's only certain values, whereas continuous would be all of the values, and continuous would be connected. So here's the words I like to write for continuous. We would write the word connected, continuous, connected. And then for discrete, that usually looks like dots, discrete and dots. Okay, a little bit of alliteration there. Maybe you guys remember that from English where it starts with the same letter. So looking at this one, does this one have dots or is it all connected? If it has dots, it would be discrete. Okay, I'll let you figure that one out, but I just wanted to throw you a bone there and help you out. What about this one? Discrete or continuous? Is this one all connected? Does it have all of the values within a certain range? Okay, even though there's a dot at each end, every single one of those values in between is included. So this one would be continuous. So the answer to number 9 is continuous. A lot of U's in that word. Okay, looks weird. All right, question number 10 again is an even number. So you guys are on your own on that one, but you guys are going to both describe and correct the error in determining whether it's a linear function. Remember, just to give you guys a heads up, remember that when we were deciding if it has a common rate of change, we look to see if it adds or subtracts the same number, okay? Look down here. Is that adding or subtracting the same number? So think about that. And then remember, for this one where we're determining if it's a line, remember what our rules are. The graph needs to be a straight line, but what about that line? What's the limitation on the line? The line cannot be vertical because if it's vertical, yeah, technically it's a line, but it's not a function. Okay, so think about those two things when you're doing number 10, and that is it for today.